Alright, we're going to continue working the stoichiometry problem. We're going to do the limiting reagent part, which starts with the same amount of each reactant. It doesn't really matter. So we're always going to pick a product. Looking ahead, the disulfur dichloride is the species that's asked for in E, so I'm going to do that one. So again, we're going to look for grams of disulfur dichloride. Okay, now we're going to start with 5.23 grams of sulfur dichloride. Okay, now as we get started, we're going to assume that we have excess sodium fluoride. Okay, so we look at the molecular weight, which is 102.972 grams sulfur dichloride per 1 mole of sulfur dichloride. Alright, then we need to convert from sulfur dichloride to disulfur dichloride. So we need a conversion factor, so we know that we need 3 moles of sulfur dichloride for every 1 mole of sulfur or disulfur dichloride. We could stop once we reach moles, but it's easier because we're going to have to do extra work anyway to go ahead and do the disulfur dichloride grams per 1 mole. This allows us to run the numbers in math. So from here we find out we have 2.286216 grams of the disulfur dichloride. Now this is more significant figures than we want, and we'll address that issue in a minute. Okay, on the other side we're again going to look for grams of disulfur dichloride. The advantage of looking at the same species is that it allows us to compare apples to apples versus apples to oranges, and it's the easiest way to avoid confusion. So here we're going to assume that we have excess sulfur dichloride, which we used previously. Again, we're going to start with the amount. Remember, you can never tell which one is the limiting reagent until after you go through the equation. So here we have a mass of 42.988173 grams of sodium fluoride per 1 mole sodium fluoride. And we look at our equation, we have 4 moles of sodium fluoride per 1 mole of disulfur dichloride and 1 mole of sulfur disulfur dichloride for 135.038 grams. Now again, we're going to run the number. Anything on top is multiplied, anything on the bottom is divided, and we end up with 4.10727 grams of disulfur dichloride. Now, at this point in time, we have to identify the limiting reagent. Well, the limiting reagent is whatever runs out first. And so that one is the one that produces the least amount of product. So when we look at it, we have to look at our products. So we go back up and we look at that and that. Those are our products, but a limiting reagent has to be a reactant. So if that's the smaller of the number, then this is our limiting reagent. So sulfur dichloride will be the limiting reagent, okay, because it produces the least. That brings us to part E, which is the percent yield. And remember, percent yield is the actual or experimental over what is the, in theory, possible, theoretical, okay, times 100. Well, theoretical is what's on paper. That's the one you get from paper. The actual one is what was done in an experiment. Okay, when we look at this, we go up here. All right, if 1.18 grams, that's going to, 1.19 grams is your experimental. Your theoretical is what was up here, and we have to look at significant figures, so that yields 2.29 grams. So we have 2.29 grams times 100. The units cancel, and we're left with a percentage, which is 51.965 percent. We have three significant figures, so we will report this value as 52.0% once we've balanced it. So we have now done limiting reagent and percent yield.